During program execution, we store single value in a single variable, but sometimes we need to store multiple values of the same data type and then process these values in different ways. For example, we may need to store marks of 100 students and then add up all these marks and finally calculate average marks obtained by the student. One solution is to declare multiple variables of the same data type and use these for calculations, but this will create a problem when the data is large enough. Second solution is to use array data structure. If you like my content, hit like and subscribe button so that I will create more valuable content for you. A collection of elements stored in a contiguous memory locations accessible by index. It is most fundamental abstract data type. Now, what is ADT or abstract data type? It is a way of classifying data structure based on how it is used and the behavior it provides. Array can store only data of the same type. Same means same. You cannot place mango with apple. The memory location in array is called elements. Total number of elements in array is called size or range of the array, which remain fixed during the program execution. The simplest form of array is one-dimensional array or 1D array, also called as linear array. Array is given a unique name and each element in array has unique position number. This position number called the index or subscript, and indexing always start from 0. This is a great debate why indexing start from 0 and not from 1. These are the ways to declare array in C++, Java, Python and JavaScript. I will give code in C++, Java, Python and JavaScript, so hold tight here. You can access array element by writing array name with the index value like array name, and inside the square bracket we have to write index like this. In this notation, A is the name of the array and 0, 1, 2 represent the index value of the individual elements. N-1 represents the last element of the array. Index of first element of array is called lower bound and the index of last element of array is called upper bound or UB. We can compute the total number of elements in an array by using this formula. Total number of elements in an array is equals to upper bound minus lower bound plus 1. Suppose we have an array A of integer type having 10 elements and is declared as A is equals to 0, 1, 2, 3 and so on. And the lower bound of this array is 0 and the upper bound is 9. So write this value in the formula and you will get the total number of elements in the array. Remember, in C++, the lower bound and upper bound cannot be changed during program execution. It means that the size of an array remains fixed at runtime. As you know, array occupies contiguous memory locations. These memory blocks are constituted by memory location required according to the number of elements in an array. Each element of array also has unique memory address. The address of first element of the array is called the base address of the array. The name of the array is a pointer to this element. Since elements of array occupy a continuous block of memory, therefore if base address of the array is known, address of any element can be computed. The formula to compute address of any element of the array is a into e minus 1 is equals to ab plus size into e minus 1. In this formula, a into e minus 1 represents the name of the element whose we want to find memory address. E represents element number of array whose address we want to find. AB represents the base address. Size represents the size of the array. Suppose we have an array A with 3 elements each of 2 bytes length. Integer takes 2 bytes in memory, remember. Then to find address of second element of the array A when the base address is 300, which is the value of AB. So how we can put these values in the formula? A into 2 minus 1 is equals to 300 plus 2 into 2 minus 1, which is A into 1 is equals to 300 plus 2 into 1. So the value of A into 1 is 302, which is the address of the second element in the memory. Now let's talk about operations on linear array. We can perform 5 operations on array, which are traverse, insert, delete, search and sort. First, understand traversal operation. In this operation, each element of the array is accessed exactly once for processing. It is also called visiting of the array. We can traverse the array in following ways in these 4 languages. The traversal operation uses only one loop to traverse linear array with size n. All elements of array have to be accessed in worst case. So the time complexity of traversal operation on average case is O of n, and in worst case is same as O of 1. Don't worry, I will explain the time complexities in detail, but not this time, because if I explain time complexity first, then you will not understand how to actually solve the problem. First, we have to know how to solve the problem, then we have to optimize it. Next, we have insert operation. In this operation, new data items are added into any location of the empty or filled array. In case of an empty array, new values are stored in empty memory locations. In case of filled array, old values are either replaced by new values or pushed forward or backward to make a room for new values. It is easy to insert data at the end of the array. Let's say we have an array having 10 elements with its first 3 elements having value 16, 77 and 66. To insert a new value which is 81 at the end of the array, which is location A of 3, we can write something like this, which is the location where we have to place new value and the actual value, which is 81. Insert value at specified location. To insert new value, values of all existing elements may be moved forward or backward to make a room or space for a new value. This algorithm explains the insertion at a specified location. Time complexity of insertion operation is O of n, because this operation also uses one loop for inserting new value into a specified location of the array with size n. Suppose we want to insert new value in the first element of filled array. The value of n elements in array must be shifted one place to right before new value can be added. Next, we have delete operation. This operation is similar to the insertion operation, and its time complexity is also same as insert operation, which is O of n. Then we have searching and sorting operations, which we will understand one by one in detail in separate videos. These are the time and space complexities of array data structure, and you can screenshot this. And that is for this video. Stay curious, keep learning, and may your code be bug free.